So I'm Dan. I'm the CTO at CLYSO, and I'll talk about. So we're so much talking about like new features and stuff like that, but actually this time I wanted to a little bit reminisce about and celebrate maybe this like 20 years. This morning Neha said she wrote 17 years old, and like so we've been arguing about this for the last 3 months, but yeah, it's actually 20. So in this talk, yeah, I want to talk more like positively about why why it's still the best storage that we can get today, best software defined. I'll do a very brief history of Ceph's first 20 years. Who in the room is like, who's been here all 20 years? Probably no one because Sage isn't here. But who's been here like more than 10 years that this is going to be history? Who's been here like 5 to 10 years? Awesome. Who's been here? Who's under 5 years? Probably the rest. That's the full set. Awesome. Yeah, there's sometimes I like to look back at the history because it kind of explains why things are the way they are in lots of interesting ways. So yeah, I'll go through that sort of agenda. And this is the proof of why I say it's 20 years old now. It was, if you do like git log -r, and then there's some kind of, actually there's some weird commits that are the oldest things. They have a date like before maybe 2,000 years ago or something like that. But the real first one is this, and that's that proof that Ceph started out as a CephFS. The first thing was mds.h. Okay, so that was 2004, 20 years ago. Yay, 20 years of awesome. So here's like a very brief history. This thing was founded by Sage Weil as a PhD project, and the whole goal was to build a modern replacement for Lustre. We had that first commit there. He published a research paper about Crush, which was like a novel. When you're doing research, you have to invent some new algorithms, and this was a novel way to look at the infrastructure and actually find a way to consistently hash objects and distribute data across, let's say, what would end up being called failure domains, right? There's lots of gaps in there. One of the most interesting things about the history of Ceph that I find personally is that the RBD driver was contributed by a user in 2010. I tried to reach out to that user recently, but the email bounced just to see what they're up to these days. But yeah, it's kind of like that positioned Ceph to be in the right place at the right time when the whole private cloud revolution started around the early 2010s. Yeah, so that's when OpenStack started with Rackspace and NASA. By then, Sage graduated, started, he used to talk. He always gave great talks. Who saw Sage talk? I mean, yeah, probably lots of people. He gave great talks, okay? It's part of why we're here. And he used to always say, ooh, after he finished grad school, it's like he was good at storage, and he wanted to, go and he could work at different proprietary storage vendors. Any of them could get a job at any of them, but they weren't interested in the technology of Ceph. They were only interested in him as a C++ developer. So that's why he decided to go this startup route and go a totally different route. Founded a startup, Inktank. There's lots of people here that worked at Inktank. The first release was Argonaut. Everything was named after the encephalopods. Josh was there in the early days too. Eventually, Inktank got acquired by Red Hat. Then things started getting really, investment into features and things. So 2015-16 is when, before 2015-16, whoever had the pleasure of working with FileStore? Anyway, yeah, exactly. So originally, the OSD used, well, actually, I don't know originally. I think there was like EBOFS or something, right? Yeah. But then it was all in BTRFS. This predates me. But when I started, it was all in XFS by then. And there was a bunch of like, oh, you want to run Ceph faster? Just mount XFS with no barrier. And it was like lots of weird nonsense voodoo. Anyway, around 2015-16, that's when, Sage and the other super gurus thought, let's not use file systems anymore. There were really concrete problems that we saw when we were operating. The first Ceph clusters that I run, those were all file store. And you had issues like the OSD just had a directory, and it put all of the objects in a directory. And then when it got to be too many objects in that OSD, it would like then put them into subdirectories, and so there was a whole other kind of splitting that existed in Ceph back then, and that was all just like, it just didn't work because XFS would stall. So that and other things led to NewStore, which then got renamed to BlueStore. Also in those good old days, every time there was a Ceph event or a Ceph day, you would learn like what's awesome. And like always since the beginning, like the Rados layer was awesome. And then you'd be like, oh, block storage was awesome. S3 was awesome. But CephFS was always almost awesome. And it was in what did I say there? It was in 2016 at, I think, an OpenStack summit. It was Barcelona or Vancouver, I don't remember, that everything was declared fully awesome. Yeah, what was required for like fully awesome Ceph was FS check for CephFS. So CephFS was working, but just need a FS scrub. Yeah, then around that time we formed a Ceph advisory board. Lots of different organizations trying to figure out how to like pool resources. That got really formalized into the Ceph Foundation in 2018. We had our first Cephalicon in 2018 as well. That was in Beijing. That was impressive as well. I think there was like 1,500 or 2,000 people there. You were there, right? Yeah, like 1,500, I think. That was crazy. That was fun. And yeah, lots of other stuff. And now we hear today there's like more investment than ever. So yeah, and this is like a timeline of things just to show kind of like when things happened. Like now we see, when we look at Ceph today and we look at the releases, it's like we're really in the like long tail of features. Like we have a very full Ceph like does basically everything, and now we just talk about the nuance of this and that, and this is optimized or not. But it's back, 10, 8 years ago, it was like key things were missing. So we had erasure coding coming in the Firefly release. Like I said, file system scrub was in the Hammer release. Joule was that first fully awesome Ceph. That's when I just threw a few of my favorite things in here. Like upmaps started appearing around Luminous. Yeah, that's like my favorite topic of all time. That occurred with BlueStore. That's when the manager was invented. The manager was invented because of these big bang tests that we did here at CERN, where we would get deliveries of like 20,000 disks, and we would just throw them all at Ceph for a couple of weeks, and yeah, broke the mons, of course. Then I was like, let's take everything that's stateful, leave that in the mon. Everything that's not stateful, throw it into something new called the manager. That's what the origin of the manager was, and other things. Of course, I'm presenting things from my point of view. Multi-MDS arrived around that time. Okay, so then, let's say Nautilus, which was, we're getting like 2019, which doesn't seem that long ago, does it? That's when the dashboard was created, PG autoscaling, tiering in S3, life cycle, that appeared then. Multi-site S3 started appearing in the next releases around 2020. That's when, see, it says like orchestrator here. Before the orchestrator, there was a Ceph native way to install clusters. It was called Ceph deploy. Whoever tried Ceph deploy? I actually never did, really. I think maybe once. Yeah, a few people, yeah. Who still uses it today? Okay, good. That would have been funny. Yeah, so the orchestrator, when it was first pitched, oh yeah, we definitely pitched that at a Barcelona something, Ceph Day. And it was about SUSE was involved, and we wanted to have just like an abstract orchestration module to handle Kubernetes, and that became Rook, to have SUSE's thing, what's it called again? Salt. Yeah, and just like a native SSH orchestrator, and that's what Ceph ADN became, was the SSH orchestrator. And then things like mclock became like the bigger features that were, and QoS, that's the kind of stuff, and of course Crimson. I'm throwing it up here, but I don't know, Crimson, we could also put it down here somewhere. Crimson was probably kicked off around, I don't know, maybe 2020. Does that sound about right? Something like that. Yeah, so that's one of the big things coming up next. So yeah, brief history. So then a little bit more about Ceph. It's like this is now stepping back. That's like the history lesson. But remember, I want to talk about like why Ceph is actually, why I think it's cool, why I still pay attention to this thing. And this is really like way back. So everything should be like, we should focus on what the problems we're solving, right? So this is where we use Ceph, first of all. It's like you start with a problem, and it's like you're building a private cloud. You heard Vincent talking today. Then you probably need object storage and block storage. You're building a data lake. It's object storage. That's what it means, but maybe some more. You want to build a fast shared file system. That's file and maybe object too if you want to back it up. Or you want PVCs for your cloud native. Then yeah, you might need all three, maybe file alone. But it's just kind of like this situation where now when we're doing modern storage, you need everything. You need block, object, and file. So that's where Ceph comes in, right? But then like the second thing is if you're thinking ahead, like hopefully, like if you're here, it's because if most people that choose Ceph, it's because they're planning ahead a bit. They're not just buying something off the shelf that looks like it. Well, they think about it, and they want to like make sure it's going to work for 5, 10, 15 years, a few generations of the of scaling and of their hardware even that it's on. So then they start thinking about. They want to avoid being locked into one solution because they don't want to get a vendor that then's got them by the data and then they're stuck there. You want something that's going to like automate your operations because, yeah, the things that Ceph's doing is a lot. It's really helpful, right? Imagine doing all of this like we used to do with RAIDs and things, like way more complicated to do that at scale. So Ceph does automate so much of what we're doing. Easily migrate the data, transfer, replace hardware, the usual stuff. But you also want to, you don't want to then have to build a team that's like investing, you have to learn that thing and that thing and that thing. So this is also part of the why decision makers are picking Ceph and why it's good. So it's just like focus on one technology that you can do everything with. That's the idea that we have with Ceph. And then you start you're exploring the different solutions, whatever is proprietary out there and whatever is open source out there. When you look at the proprietary ones, maybe they look simpler to operate. Certainly they'll say that, and probably they are, but they're definitely less flexible. Almost always will come to that conclusion, and they're going to lock you in. Yeah, maybe that's okay to be locked in, but normally then if you're choosing Ceph, it's not what you're looking for. If you look at open source, okay, you're controlling your own destiny. So then you look at what are the different open source options, right? So I think normally then the path that people go is they're like, what's everyone else using? And this is the thing that we showed this morning. It's like everyone's using Ceph. In the OpenStack world, everyone's using Ceph, right? It's like 82, so I think it's like 85% now in this year's, right? So you can click that if you want to see the OpenStack analytics. And then one thing that's curious, we don't get very clear statistics on the CSI driver usage. I'm not sure that data is collected anywhere. Do you know if it's collected, Robert, anywhere? Yeah, I don't think it's collected. Yeah, but what you can get is CNCF publishes which of the graduated projects are used in production. Like purple is production, and I guess that's gold is evaluating. And well, only 71% of CNCF users are using Kubernetes. That's a good baseline, right? Yeah, so it's like a sanity check. Anyway, well, Rook's here. It's, if you do the ratio, in the end, it's like 1 in 5 cloud native users that are answering the survey are using Rook. That's pretty impressive. Actually, I think that's pretty impressive. We don't have those CSI statistics, like I said, because if you want to know, basically the question I'm trying to answer with this is how many cloud native users are you actually attaching to a Ceph cluster? You'd really get that from the Ceph CSI driver statistics, but we don't have it. Anyway, ChatGPT says it's definitely the number one of the open source on-prem drivers. The number one is going to be AWS, CSI, and those things, the Google one, the Azure one, but then the first one that it lists is Ceph CSI. So yeah, you can click that. That's interesting. So why is everyone using Ceph? Why is it often? Okay, it's the unified thing. So that's the thing. You can just focus your effort there. And then it's you go into Dan's favorite topics, which is the original, when I first looked at Ceph, it's the core foundation is correct. And what do I mean by that? It's because the most difficult problems when you're building a distributed storage system that I've seen, it's how do you keep track of billions and billions or trillions of files. Okay, that's one question. And then it's like, where do you put them? So should you put them like just randomly here and there? Should you like group them, put them somewhere? Like, is it faster if you put them here, or what if you want to make it cheap? Like all of that. And it's like Ceph has the answer to these things. And that was Crush, which was like kind of a research project. And then it was also placement groups, which is my favorite topic because nobody talks about. People think these are like annoying or something, but it's actually this. It's the real secret spice that makes Ceph so good. So we know what Crush is. It allows us to avoid the use. The question is like, how do we locate the files? How do we locate the objects? And Crush is the answer to that, basically. So we use this algorithm, which is like a consistent hashing algorithm. So it's just a bit of code that takes some like configuration, it takes a name of a thing, and it gives you a location. And it also, like the whole innovation here was that it gives us that language so that we can describe how we want the data to be placed. And that was like the key insight, right? Like we want to be able to maybe put copies across data centers, in different rooms, all of this stuff. This is very like, it seems like, to us that have been using Ceph a long time, it seems like kind of obvious. But this is all really innovative key stuff that you don't have in other systems. It's really fast. So this algorithm is fast. So it's like you can do it again and again and again. And I think we concluded today that it's like, it is doing it again and again and again. It's not, it's something that I think should be cached. So that's a discussion with Greg that we were just having. And these things are all really small. So it's like, this is all part of like the architecture of having a thing that you can just share with everyone. And so yeah, this is step one, that's Crush. You can make a reliable and scalable system. The second thing is those placement groups. And this comes, like why are placement groups, why do I always talk about them? This is this interesting thing where you're deciding how to actually do redundancy. You either replicate whole disks or you replicate whole objects, like single objects, right? If you're replicating disks, then you have to have a spare all the time or you make a new one. If you're replicating objects, then they're all kind of coupled with each other. The cons of this approach is that you need an empty spare to recover all the time. And the recovery is also really slow. So if disk B here fails, you have to just sequentially copy all the data at the speed of a disk, which actually a modern speeding disk is about 250 megabytes a second, so it's getting better, but if the NVMEs that people were walking around in their pockets with at supercomputing 2 weeks ago are 122 terabytes each now. So this is just like, forget it. You're not going to replicate those things, and because of that bottleneck. Replicating all the objects, maybe that's interesting. Let's do it one by one. The problem is that then if you have triple failures, this is an availability challenge. If you have multiple things failing at the same time, it means you're going to lose data. So this is why we don't do this. So those two options are out of the, can't do them. There's other storage systems that do those approaches, of course, but the clever insight in Ceph was placement groups. Group these things into a thing called a PG, put the object in the PG, and then replicate or erasure code, make the PG itself redundant. It means that very few triple failures lose data. And when I say that, like actually we were talking about this yesterday and they were worried about, should we do the racks like with this, like if we have maybe 4 failure domains or if we have 20 or something, like it's going to make a big difference in how many of the failures are going to happen. But if you do the math on these numbers, like the number of possible, if you have like a 5,000 OSD cluster or a 1,000 OSD cluster, even with 1,000 OSDs, there's a billion, there's 1,000 times 1,000 times 1,000, it's a billion ways that disks couple to each other. And that's like a billion ways that you can have things failing. But when you use PGs, it's like maybe you'll have, I don't know, 10,000 PGs on that cluster or 5,000. I can't do the PG calculation like that, but it's like, so that's like 5,000 over a billion. That's the odds that one of those triple failures will lead to data loss. It just doesn't, it's astronomically low. So that's why PGs actually make Ceph reliable. It's an availability benefit, but it's also a recovery benefit because it means that when one of your disks fails, you have the recovery happening, like all the PGs recover at the same time, more or less, right? So that means that now we have a default of 100 PGs per OSD. It means that you have 100 things, if you have a large enough cluster, like 100 disks all recovering at the same time, and it's only 1/100th of the data goes to each of the other disks. So it's very fast. It can just take a few minutes or a few seconds to recover from a disk instead of hours and hours. So that's all what makes Ceph great. But then I have some more, like, let's call it like anecdotes from stuff I've seen where what makes Ceph like interesting. One of the main design, or like let's say design goals, is like Ceph makes a reliable storage service out of unreliable parts. Okay, so, and I'd say it like a different way. It's like it's better than the things that you make it out of, and it's like actively debugging your IT infrastructure. That's my real operational experience. So Ceph versus the network, like here and elsewhere, I've seen like unbelievable, like you probably have as well, I've seen unbelievable network issues. For example, like packets being corrupted silently. When I say silently, I mean the checksum is still good, but the packets are corrupted. That's a very easy thing to happen in a TCP network. Ceph notices those problems. Maybe other applications that aren't doing their own checksums on top might not notice those. Ceph versus Linux. There's many examples of Ceph finding memory allocator or kernel IO bugs. One of my favorite, I don't know, I've got like my CERN badge and it's like this deer in a headlight look. Like this was when this was in 2020, this was this LZ4 corruption bug where there was an extremely rare data corruption that happened because of the compression library liblz4 that was shipped with all the OSs at that time, and yeah, like Ceph found this bug in the library. I mentioned before, like these file systems like BTRFS and XFS, they're just like not predictable enough. They're too unstable. That's like sort of debugging. You know, Ceph is better than these things. It had to build our own local backend. And then, you know, we find so many hardware problems with Ceph. For example, all recent generation. Oh, gee, I have to, like, what does recent mean? Like all HDDs in the last 4 or 5 years, larger than sort of like 12 terabytes in size, if you plug them in and they have their volatile cache enabled, which is often the default, depending if you're buying like where you're buying them from, they're like unusable in Ceph because they have something called a media cache, or different vendors call it different things. And until you switch that thing off, like the way that Ceph uses these disks, it's turning, for example, like a very quick, maybe a 4 kilobyte flush into some kind of like many megabyte flush. So just ruins everything. So when we discovered this, it's like we talked to several different hardware vendors, and it was almost impossible to find anyone that understands why this is what's going on. But yeah, in the bottom line, it's like, do we just switch it off? We found, Mark did this more work, it's like the power loss safe. We found lots of NVMEs that lie about whether or not, like that they, you know, have a supercapacitor or whatever, that they're safe, that's flushed. We found devices, there's many devices that don't, you know, they don't persist the data. Mark's added some QA tests, the NVMe standards actually to you know, to detect in order to qualify the devices. We've come across in the last I think like 6 months, like 3 or 4 really nasty NVMe or CPU bugs that I'm sure many of you have seen, or I hope you haven't, but things like one vendor of CPU, if the thing's running for 1,044 days, it syncs up, it freezes. There's other NVMEs with a certain uptime. We've seen these all in the news probably. Certain uptime, they also lock out, like disappear from the SCSI bus. Luckily, in those 2 cases, reboot fixes. But we've also seen, recently I saw an NVMe that if it's idle for 1,000 days, then it just dies. It just like bricks itself completely. So that was really scary because, like, you know, some people might have some kind of archive cluster where they've stored all their data and they just don't touch it anymore. But yeah, they go to get it eventually and everything's completely dead. So actually Ceph like found these and still survived these because luckily they don't all fail at the same time. Yeah, like things like the IOMMU being slow. We found that in recent, this was related to that 1 terabyte per second test that we did. Like, switch it off on latest hardware. It's like lots of different things that you notice with Ceph and with Ceph technology. Okay, this was this. A lot of people, not a lot, but like you hear this kind of FUD sometimes that Ceph is not fast. It is like it is very fast. Maybe maybe you have to do a little bit of work to make it fast, but I think personally, out of the box, if you set up a CephFS, it's like it's faster than a local disk. It's very fast. Sure, there's like maybe some complexities that it brings, but Ceph is definitely fast. That's why people pick it. And then also like it's like in the part of the like sort of marketing and branding that we used to say, and I'm trying to like revive this, is that we used to say that we want to build a Linux of storage with Ceph. That was like the idea back then. And it's like, I don't know, these things are evident, right? But somehow I just want to like think about them and remind like, what does it even mean? Like, because now we take Linux for granted. Like, but what is even Linux? What happened there? Why did Linux even succeed? And it's like a combination of things. It's not actually that obvious. First of all, it's free and you're not locking in. That's like obvious stuff, right? But like to the more important stuff, it's like many organizations use it as like a platform for innovation. Like you can't, and Ceph is used like this quite a lot. There's a lot of like grad school researchers throwing their erasure coding plugins in there or different ideas to optimize this and that. Like Ceph is in a way, it's like a platform for innovation. It's very important that the open sourceness of Ceph is like critical to some of the, in the different global areas that you can look at something and trust it, like for security and things like that. Like that's essential to many of the users of Ceph. So when we look, like also, when you buy an appliance storage, the quality of the feedback that those kind of appliance vendors get from their users is not always that valuable, right? So when you have our community like Ceph, like with Linux as well, I mean, this is about Linux, but it's also about Ceph, obviously. It's like if you have users that are focused, their organization asks them to focus and learn this technology, and they're curious and they dig into it and they can spend time and deep dive and get quality issues or maybe even some pull requests. Like this is like the most valuable thing in making the technology better. It's like that's perhaps like the main reason that Linux got better. Yeah, and then of course it's like longevity, so it's sustainable. It's like it doesn't depend on any one organization. It'll just survive no matter what. Yeah, so Linux's success was built on all those things, and it's like that's what Ceph is. That's what we need to always make sure that it stays like that. It's those things that I think about now with Ceph at 20 years, and that's this like more about the community. Most of those ideas came from outside, from users. And I have some like very specific examples. Like I said, the RBD was contributed by a user in 2010, so that's Christian Brunner. Does anybody know him? No. Yeah, it's a bit incognito, this guy. BlueStore was also, I remember being fascinated watching the BlueStore discussions going back and forth. This was 4 or 5 organizations all contributing, like, ooh, do it like this. But it's a lot of like very deep technical knowledge. There's few people in the world that can design a thing like that. So that was like Red Hat, SanDisk, and other orgs working on that. Right now Samsung is we were over in the Open Infra Summit and the Ceph Day in Korea, and Samsung is like investing a lot in Ceph right now. Actually, probably we'll hear something about it next year. And like they're focusing on, in particular, dedupe, but like more stuff as well. So that's another external, right? And Crimson is also a collaboration. IBM, Intel, things change a bit, but it's just here's a word cloud of the types of organizations that are contributing to the Ceph Reef version. It's like tons of different organizations, right? So that's why Ceph is good. It's like all of this diverse input, unique feedback, unique experiences, put it all together. It's like you evolve the thing that is going to survive and be the best. Yeah, that's it, somehow. Ceph, 20 years. Thanks a lot.